Yes.
Triangle.
Otherwise, it's known as a pedal triangle.
Yeah.
Have you guys
So
actually done this? Like, how many time lessons have you guys done?
Oh wow.
Or you just
I
want
mean,
to
like,
make
it's so boring. Like,
Can we do like? We'll do like
can we do actual functions?
You just tell them
I don't
to do
mind
it.
learning functional.
Can you do functions? I'd rather do this.
Functional equations.
Have they seen that? Wait.
Oh yeah, have you seen this?
You're gonna complete a functions boring after that.
Dude,
Is functions boring?
What's the main function?
so let's get the main function question. See how
That's a
long.
really good- yeah.
If it takes them like more than 2 seconds to look.
Okay, good. Yeah. Wait, let me try.
alright, so one of the things I want to say.
What's that
Is
function?
it this one?
Yeah, it is. Because if you do substitution, it's correct.
Oh no. Oh wait.
Wait, what's the function?
It's fine. Yeah.
Wait, what is the function?
That.
Oh no, it's not the right one.
Yeah,
It's
it
not
is.
that one.
That is.
Is it actually?
Yeah. Well, it's that equals that, but yeah, the same one. Because
This is
if
A1.
you do the substitution.
Oh yeah.
Wait, are you trying to work out?
Oh yeah, it is. It's fine.
Yeah.
Right. Okay.
I'll write it out.
Wait, you like functional equations, right?
Yeah, so basically the way to do it with Simpson's line, right, is you find an expression for A1, B1, yeah? Okay. Can you see
Wait, A1, B1.
can you see A1, B1?
Yeah.
What's the sign rule again? So
Oh.
basically the extended sign rule. So you have A1, B1, right?
Equals.
Is the diameter of
This quadrilateral.
so it's the diameter of
30 seconds.
Oh, actually, no. It took me longer. It probably took me longer.
30 seconds, cool.
Oh,
Yeah.
easy.
so can you oh guys, so can you see
Wait, what are functions?
Can you actually? I need to actually.
So- so sorry, now AP is the diameter, yeah?
Yes.
Okay. Of that quadrilateral, yeah?
Okay. Yeah.
And so it's equal to 2 times the radius. But like, what's the sine rule? Do you remember the sine rule?
Yeah. It's just.
You have like,
The side on the. It's equal to.
so if you look at this triangle, for example, right?
Is it?
Yeah?
Yeah. Oh. Okay.
A1, B1 on sine A, yeah?
On side A, yes.
Yeah?
Yes.
Yeah.
I don't
equal
understand
to-
this. Could you explain it to me?
Equal
Is it
to
2
B1.
R?
Yeah.
Two. Yeah.
Wait,
Is
is
equal
it?
to A, which is
2R.
equal to AP. Right. Yeah.
Is it equal to 2R?
Yeah.
Wait,
Alright.
how is it?
Because our sine rule is equal to diameter of circumference.
Oh yeah. Oh yeah, that's the extended sign.
And we proved
Or
it.
is it upside down? Or is it...
It's fine. Otherwise, it'd be too small. Yeah.
Alright, okay. Alright. And then you know that sine A,
Oh wait, we're using.
little a is equal to, it's
Wait,
the
what?
same thing, right?
Yeah.
2R. Yeah?
A. What's little a?
Wait, what?
Little
Why
a
are we
is this-
using?
Oh.
Huh?
Sure.
Why
So
are
is it
we
from
using
here to
this
here?
diagram for Tom?
Is it from? That's the.
That's the point. That's the
Is it CD or DC or
that's
C1D?
the point of this presentation of Ptolemy. Yeah?
Wait, it's CD, right? Not C1D.
A is CD, yeah. CB.
Could you explain that question to me?
Okay, do you know
Oh,
what functional equations are?
Yes.
Yeah.
I didn't know this.
Can you not just randomly do other stuff?
Yeah, I know, right?
Oh, you can, but like, don't interrupt other people to do it with you. All right, so can you see? So the point of this is to eliminate sine A, right? So you have A1, B1 equals what?
Equals
A times
sine A. A sine A.
A AP on 2R.
Yep.
Yeah.
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 Similarly,
So R is this distance, right? AP.
B1, C1.
Oh.
You do B1, C1.
Jeez.
Yes.
What would B1, C1 be?
B1, C1 is like C, and then CCP on R, like onto R, I guess.
Big CP on 2R.
Should be something. Should be my symmetry.
Okay. Yep, and then I guess we labeled them a little bit differently, but and then we have AC1, right? A1C1.
That's B and then BP on BP on 2R.
Yeah.
I think it should be that, but it doesn't.
Wait, which
not
one's
quite
A?
sure.
All right.
It seems weird, but B.
Well, we just have to check these are the diameters, right?
Yeah.
So B1C1.
Is the diameter.
So the diameter is CP, yeah.
Right. Yeah. Hang on. Oh wait. I guess CP is the diameter. Yeah.
Okay, so that's fine, yeah.
Yep.
And
And
then
then BP is the diameter. Yep.
A1C1.
Yeah. BP is the diameter.
Are you sort of sign A for both first and second? For AP and.
Yeah. BP is diameter.
Because are you talking about A sine A and sine A1?
So it's sine A is this angle, yeah.
Yes, but like, why is it A over sine A? Like, it's
So-
shouldn't that be like that little angle?
So we're doing two things here, right?
Yeah.
So we're doing this angle here over this side, yeah.
Yeah, so that's
That's
A over
this.
sine A.
Yeah.
But like,
And
what's,
then on the other one, we're doing this triangle. A1, B1 on
but
this
that's a
angle.
different angle. Why you?
But it's got the same sine value.
Oh, okay. Because like 100, it's a straight line, 180
Yep.
degrees. That's
Okay.
clever.
Alright, guys. So try to be proactive. If you already get this, what's going to come next? Do you agree with this formula so far?
If you move it, let me think. It'll be AP sine.
See, because because it's collinear, right? Collinear means A1 B1 plus B1 C1 equals A1 C1. That's what collinear means,
Why
right?
do we have the 2 on there?
That's the radius
No,
of the
but
circle.
like, because the top line you have equals 2R as well.
Yeah,
Yeah, so you have, yeah,
this one, yeah.
yeah, so like, so that equals 2R and then this equals 2R, so therefore,
No, but they're different they're different circles. So this one's this circle. The radius is the
wait.
diameter is AP.
Oh, the 2R is the diameter of the big circle.
Oh, you meant that was, wait, what?
AP
So
is
this
the diameter
is
of
on
the small circle of the
A1
Oh,
B1A. That's that triangle. The circumradius,
so the AP is
the diameter.
that.
Yeah.
But like, I just falls the same. Okay, yeah. Thanks.
Yeah. Yeah. So now because it's collinear, right? That's the whole point. Yeah.
Mm-hmm.
It's on a circle. So if it's a cycle quadrilateral, it's on a circle, right? And so therefore it's collinear.
Yeah.
Right. So if it's collinear, that means A1 B1 plus B1 C1 equals A1 C1, right?
Yes.
Okay.
Oh, wait. And then yeah,
And then you add them up. So the two R's cancel, yeah?
wait.
There's- okay, I'll just write them.
Oh, okay. Yeah.
AAP on 2R plus
What did this
B. Huh?
Never mind.
What?
Never mind. Yeah, they cancel. Yep.
CP on 2R, right? And so AAP plus BBP.
Oh, it's
C-
no, CBP. B is wait, hang on. Oh, wait, no one.
Oh, it's BP.
Is that,
Well, I
yeah,
think
that's
something-
just, yeah, that's
Oh, BP, yeah.
Yeah, BBP.
Yeah, that's just,
BB.
Yeah, so and then
Wait,
C.
did I-
Says,
So is that
this is
C?
C. Yeah, this is C, and then this B. C,
Is that what you meant,
C,
Sean?
CP. And B.
oh gosh.
BP, yeah.
Yep.
Yeah, that's what you meant, right? Okay.
Nearly done.
Yeah, and then A is BC, right? So you can think of P as D, yeah? Yeah. So this is BC times AD plus
Oh, what's that?
AB.
AAP plus CCP equals BP.
CD, right?
Is equal to
Oh.
AC times BP.
No, it's CP, not. Wait. It's CP, yeah, not CD.
B. So I just changed P to D.
Oh.
Okay.
I just changed P to D at the end.
Oh, okay, that
Yeah,
works.
so you can change
That's
the
beautiful.
P to D again.
Oh, so why is... Oh.
Oh, that works beautifully. Yes.
Oh,
Nice.
it's
It's not as beautiful as the other.
Wow, trick.
It's
Amazing.
almost not as beautiful. It's not as beautiful.
Does it raise all the bottom and you get these again?
Okay, that took way too long.
No, it doesn't.
We have to use pedal triangles, right?
That took way too long.
That's
Hello.
That wasn't long.
So like
Yeah.
Ptolemy, I don't know how long Ptolemy spent on it. But
Definitely not long enough to justify you calling this.
yeah.
But like I'm looking.
But this is like obviously not the only proof. There's this other proof.
Cosine rule.
No. No trick required.
No ugly trick.
Come on.
Solve this shit.
Why would you
So
want
what
trick?
solve for what? Find all functions.
This is beautiful.
Fx is y.
This is beautiful.
This is good. Oh yeah. So something about a converse. So people are saying the converse is not true, but it says this has a converse that can be strengthened by observing that for any location of B1 other than on the segment A1, C1, the equation has to be replaced by the triangle inequality.
Two variables.
Well, like anything will affect
I haven't dealt with two
Hmm.
variable
That's
That's
actual
not.
equations are...
Well, most functions don't really that.
Oh,
Unless you
okay.
have, like, F
So I guess it's saying something like if it's not collinear, right?
Yeah.
Then you replace the equality here with triangle inequality,
Oh, okay.
and then you get some sort of
Let's say
converse.
x equals 0.
Good.
So I guess if it's not collinear,
Wow,
if P is not on the circle, then you get a
Yeah, you have.
I have.
So now it's just.
Oh, okay, yes, I know. Fx.
So if ABC is a triangle and P is not on the arc CA,
Hey, good job. So nice.
so this is, it seems to be stronger than the converse in some way.
But it's stronger.
Yeah.
The converse is stronger.
So if you have a P, right,
Yeah.
and it's not on this arc AC, right, then the left-hand side is greater than the right-hand side. That's what it says. So in particular, if it's not true, right, then
My brain. Then it has to be. It's the being true is the minimum bound, right? Of a
yeah, so being on the circle, on the
Is-
arc,
is
gives
the
you
min-
the equal.
is
yeah.
the minimum bound. The lower bound. Is that correct?
So and if it's not on the circle, then
A1, B1
That
plus
is not
B1,
true.
C1 has to always be greater.
Why?
What?
You must have to what?
No, not now. Not at all.
Oh,
Okay,
it's
so-
a synthetic.
yeah.
Yeah, synthetic.
So I guess if P is not there, right,
Yeah.
like it's not on the circle, then this is not a straight line anymore.
Yeah.
Right? So then this plus that is bigger than that. Yeah? That makes sense?
Yeah. It's not really clear, so
Yeah.
A1, B1 plus B1, C1 is going to be greater than A1, C1.
Yeah.
Uh-huh.
So the converse is even stronger than the converse.
What?
Okay, or the actual one.
Because the actual converse would be just like if this is not on the circle, right? Then this is
it's
not equal.
Oh, but it's actually good. Okay.
Well, like that's not the
So it
that's,
tells you
that's
a
the
bit more.
inverse, right? But it's equivalent to the
So
converse.
it tells you a bit more, I guess.
Yeah.
What's the difference between the inverse and the converse?
Logically, they're the same. But inverse is just not in A implies not B, right?
Yeah, I think.
If
I
A
can't
implies,
remember this because I didn't ever have terminology.
if
So
A implies
Oh,
B,
no, no.
then not.
you have
okay,
inverse, converse, contrapositive.
Contrapositive is same as.
Yeah, so the
Contrapositive-
inverse is the contrapositive of the converse.
Okay, right.
Contrapositive of the converse.
Oh, okay.
Oh,
Yeah, I see.
So if the A implies B, then the inverse would be not A implies not B, and then the contrapositive would be not B implies not A.
Oh. I still wish I could figure out this other proof.
Oh, so there's,
We will-
so
we can
there's
do
one
it.
for
Huh?
all four directions.
I guess we do it.
Because it makes you wonder, like it gives you, like it's not like everything has one proof, you know, and like how you prove it actually shows the interesting connections between.
Yeah,
Different
wait,
things.
Wait, don't show it.
So what?
Wait, there's one, can you guys help me do this one, for example? So there's like some cyclic quad, right? This must be something like this. So this is like alpha, and this is this
Yeah.
guy just screaming alpha the whole time. Okay.
Can you show it to us? Can you show it to us?
I can't find it.
Send the link.
Yeah, I'll find it and I'll send it to you. Okay.
It will be pretty
No, but it's funny
Like-
if you watch the
Yeah, it is.
You don't laugh if you watch it by yourself.
So-
you probably still will.
Yeah,
You're
but
trying
like,
to move.
Yeah, wait,
You
wait.
move
Wait.
one triangle.
Can you use your phone? Can you use your phone?
Why?
Find it.
Sure.
Okay.
Well, that's not right.
I'll just go on YouTube and try to find it.
I think a plot is means equation proof.
Zero. And it's by Hindi guy.
don't say by Hindi guy because you won't find it by him.
The proof explained by Dika.
What are we doing now?
So I'm trying to move this triangle. Okay.
Oh.
Over here.
Oh.
Oh, so
Even more advanced
basically
construction,
doing
okay.
So then you get some.
Wait, what?
Wait, what?
Wait, what did you do?
What do you?
Oh, you mean are you rotating it about B?
Yeah, basically.
About A, right?
So this
About B.
Wait, about B.
about one of the points. And this is what's confusing me because I can't remember. Like
Oh, yeah, isn't it like the
You-
same thing?
you move it over there.
Is
Yeah,
it?
it's like the same thing, right? Like,
Is
then
it?
where you join it up together.
Oh, sure.
It's
And
like the
that's
same
alpha,
thing.
right?
Like if you join up those two.
Yeah.
How's that alpha?
Yeah, that's like the same.
Wait, is it alpha? Wait,
Yeah,
why
it's
is it
like the
alpha?
same thing as our proof, except we didn't use this bit.
Yeah.
You just have that angle as that angle.
Wait, how do you get that to alpha?
What? This.
Yeah.
Because that's alpha here. You're just moving
Which is-
that.
Oh, okay,
rotation
yeah.
of the thing on there.
Yeah. So you can do it without that pi and just put that out.
Huh?
So like,
Oh yeah. Okay. I think I know how to do it now. So.
Yeah.
So you move it over there, right?
Not like
Okay. You move it over. Now it's alpha and alpha, right?
Yeah.
So it's similar, yeah.
Yeah.
So then AB on BD, right, is equal to BU. What? No, AU on.
AB.
wait, AB on BD is equal to BU on like that thing, which is like
C prime.
BU on BD.
C, isn't it?
B.
yeah.
Basically
BU on
CD,
BD.
right?
Oh, BU. Wait, BU.
AU on CD.
Hang on. AU on CD. Yeah, sure.
Is that right?
BU on. Yeah.
But
Yep.
Yes.
Okay. So then AB times CD, right?
Yeah.
Is equal to BD times AU.
Yep. And then you use the other side of the triangle.
Yeah, and then you can move it to the other side as well.
Oh.
Uh,
Okay.
So so we move the diagonal BD over there, yeah? So
Yeah.
now we want to move the other diagonal over here.
Right.
Which way do you want to do that? So maybe we want to do beta here.
Okay.
Jeez. Where's the other
Oh,
diagonal?
wait, hang on. No, I don't think.
Wait, why is AB
Oh.
on BD?
And then.
Because it's
Oh, yeah.
triangles.
And you move this to that side, right?
And A,
Oh,
B
oh,
over that
CD.
BD.
You mean C?
Yeah,
oh,
you
you
mean-
mean that's
AB,
CD.
so it's not AB.
So you
You move.
Oh yes.
that's CD.
Well, you do the same like
Is
movement,
it?
right?
I don't know.
Because you move the.
What AU and what?
You rotate it about A.
Got A.
Yeah, you're right. AC
What?
B about A, I think.
Wait, can you name this C dash and D dash?
So you make this C. Like,
Wait, can yeah,
I know.
D dash. So is that
You're
is
doing
this
Uh,
which one is it? Like one?
Wait.
So this one, you take BCD, right, and you move it so that it's
Yeah.
in line with AB.
Yeah.
So the BD is in line with AB.
Yeah. Wait, so which D is this one implying? Like which D and which C is it?
Oh, so this is C prime.
And then is this D prime?
Yeah.
So this is D prime. So what's this now? D C double prime. What? I'm so confused.
Maybe I'll use another color.
B on BD.
Oh, I found a video.
It's more energetic than that. No, it's more energetic than that.
Wait.
Like
So
this
which-
guy is going for views.
Which D is this? Is it this one or this one?
It's the image
Doesn't
of that
matter.
one.
Doesn't matter. It's the
Oh,
same.
so it's D dash.
Yeah,
CD
but they have
is
the same length,
thing.
right?
Like
So confused.
we just rotated CD.
Yeah.
so
Yeah,
it's
sorry.
the same
This
length.
is BD prime, yeah.
Oh, okay, that makes more.
But it's the same thing.
Yeah.
Is it the same?
Yeah,
Oh,
'cause
Yeah,
the
this
thing
is
like
it is the same.
You just move the same length over there, yeah.
Oh.
Okay, so we need basically the same
Oh.
relation, but for the other diagonal. So maybe it's CD on
Wait, how is it
AC,
AU?
right?
Yeah.
What
okay.
length is even AU? What triangle
Oh,
is AU prime?
Maybe we rotate like this one down to here.
Yeah.
Yeah. So then you have like this sort of thing.
That's equal to UC.
Wait, wait, we still want to be using the U though, because we need the BD part. BU. We need like.
So we end up getting something like CD times A. So this should be AB on
Something like this is pretty.
Half that water. That's good.
Jeez, I had it just before.
Why don't you have it now?
I don't know. People just lose stuff.
Wait, why isn't it?
Why don't you have it now?
Why is AU so?
It's just the same like me. I forget proofs I did half an hour ago.
I'm sure there's another similar triangle somewhere.
How far?
Wait, how AU? Do you mean that distance? Over.
Why is everything?
Okay, so let's try to move AC to
yours?
here then.
Exactly. It's like you grab my stuff, I try to get it out. You hold on.
oh yeah,
I
that's
ask
true.
you, is this yours? So like, rub it.
No, I just like grabbing it.
Then you get AB on DU.
Okay, thanks.
Yeah.
You get really? I don't know. Wait.
Put it like this.
So if you move that A down to here, okay.
B somewhere after.
It's like you're thinking.
I'm thinking very hard right now.
Some angle
Yeah.
alpha still, right?
B
Yeah.
somewhere there.
Wait, which
Yeah,
one?
I'm like V.
Whoa.
But then like.
Oh, is that the other
No,
triangle?
it doesn't make it obvious.
Isn't it B?
Wait.
Isn't it B not B?
Oh, okay, again, I think it might be. Maybe it's better to move BD now on BC.
Okay.
Because then it's kind of obvious now that this line has moved across A and C.
Yeah.
I think that's important. So if you put this here, right? That's BD with the black
Double prime.
black D.
One.
Yeah, and then you
Wait,
have.
so which two triangles?
Yeah, but like, how are you gonna cancel out your U at the end?
Yeah, that's the point. So this becomes here,
So D becomes D.
and then A prime here.
Uh-huh.
Yeah,
Wait, what?
Sure.
something like this.
You rotate triangle ADB about B.
A or
Yeah.
BAD about B.
Yeah, and then you get something here, right?
Yeah.
And this is parallel. Yeah.
Yeah.
So then you get BC on BD. Yeah.
Because you just wait. Why is it parallel?
Because two gammas.
Equals AD
BC over BD.
on CV,
Wait, is
right?
this all similar triangles?
Yeah.
Yeah.
Right?
Yeah.
So now you get AD times BC.
Yeah, how are you gonna get the two other angles? Like, how are you gonna fix the cancel? It's gonna be hard to cancel out the U and V.
So I'm meant to get something like this again. Wait, so I'm meant to get, so A, B, and CD, right?
Yeah.
I'm meant to get BC and AD. So, yeah, that's this,
Yeah.
yeah? Okay, good. So I got BC and AD, yeah?
Mm-hmm.
And it's equal to BD again, right? The common factor of BD, right?
Yeah.
And CV, okay? And this one is AU, right?
Uh-huh. Oh,
So,
I see. Well, you
yeah,
have the
so-
BD now. And
yeah.
then the AU.
So the
plus
AU
CV.
plus CV is going to equal AC
Yeah.
because it's meant to span this whole diagonal, like when you rotate. So you could,
So how do you prove that? Wait, really?
well, the point is when you move this up here, right?
Yeah.
You've moved it across that angle there, right?
Uh-huh.
If you move this, did I just move that down here?
Yeah.
Then you move that across the same over here. Does that make sense?
Okay. Wait.
So
Oh yes, I think I get it.
It doesn't like.
I get it. Because although it's disconnected, you see it's disconnected U and V, but it's actually like because you rotate it, it's a smaller portion. So in fact, it does cover the whole thing.
yeah, like when you move this over to
BAD,
that
for
line,
example,
right?
when you move BAD,
It's this angle at this point, like that angle is how much that covers, right? And then when you move this over here, right?
And they sum up to
Yeah, that angle is covered the other way.
Okay, yeah.
Oh,
So the point is AU plus CV
Yeah, and AU plus CV
is equal to
AC.
AC.
In other words,
You have the angle beta and the other angle, right? So when you rotate it, like the amount it covers is still like that beta amount. Yeah. And then the other amount that gets covered
we
is
have
like
another
the
sleeper.
other.
oh,
So then
so it really should
yeah, they
so
sum
it
up
really
the
should
AC,
be
right?
the same.
So
So
then
now
it's
you
all
prove
A
that
plus
it
B.
should overlap. The BA dash should overlap BD,
Yeah.
and A. Oh, that makes so much sense now.
There's another one.
Yeah, he didn't really explain any of this in the video. It was just like
Where you,
alpha, beta. So I got the essential angles recall. I saw the similar triangles.
So it's like
and then you have some similar triangles.
Yeah.
The similar triangle. This triangle is similar to this.